Okay, right, grade 9 maths problem. I've got a drawing of a miniature nail, and the nail is comprised of a hemisphere, a cylinder, and a cone. The volume of the hemisphere is 144 pi millimeters cubed. Length C is half length A, length B is 5 times length C, the head of the nail is twice as wide as the stem. Calculate the volume of the miniature nail, give your answer in terms of pi. Okay, let's go. So, first things first, let me see. The volume of the hemisphere is 144 pi millimeters cubed. So I should be able to work out A. So the volume of a sphere is 4/3 pi r cubed. And that's just one thing that you have to know. So the volume of the hemisphere would be 2/3 pi r cubed, because it's just half of 4/3 pi r cubed. So let's substitute in the values, because we know the volume. So 2/3 pi r cubed equals 144 pi. If I divide both sides by pi, I've got 2/3 r cubed equals 144. So I now need to divide both sides by 2/3. So if I divide this side by 2/3, I have to divide this side by 2/3. I'm going to take this as if it were non-calculator paper, so I'm going to just have it do 144 divided by 2/3. So that's the same as 144 times by 3/2, or 3/2. So that would be times that by 3 and then divide by 2. So 144 times by 3. Well, 144, 288, 432 divided by 2, which gives me 216. So 216. So I've got r cubed, once I've divided by 2/3, as I've shown here, equals 144, which is 216. Now you may not know that the cubes up to the cube numbers up to 216. So I would enable you to use a calculator. It is actually 6. 6 cubed is 216. So you would do cube root 216 equals 6. So r cubed is 216, so r is equal to 6. And it's millimeters that we were talking about here, wasn't it? So I've kind of got the really important information that I needed to extract at the start of the problem. I can now sort of just work it through. So if r is 6, this length here, A, must be 6. And then it says C is half of A, so that equals 3 millimeters. And it says B is 5 times C, so that's got to be 15 millimeters. And it's twice as, the head is twice as wide as the stem, so my radius of stem, it must be equal to 3 millimeters. If my radius of this one is 6, my radius of the stem has got to be 3. That would make it half as wide. Okay, calculate the volume. Alright, so we're just going to take those 3 different parts. So we've got the hemisphere. Pen's being a bit dodgy. A hemisphere. And that is, we already know that, 144 pi millimeters cubed. And then we've got the stem part, which is the cylinder, and that is Well, pi r squared h will give me the volume of a cylinder. So I'll just write that down. Pi r squared h, which is pi. R is 3 for that, so 3 squared. And the height here is 15. So that's the same as pi times by 9 times by 15. Now 10 lots of 15 would be 150, so 9 lots of 15 would be 135. So that's the same as 135 pi. Again, that's millimeters cubed. Okay, and then all I've got to do is the cone part. This is for question A, isn't it? The cone part. So the cone part is 1/3 pi r squared h. Different h here. This time the height here 3. So let's substitute in what we know. So it's 1/3 pi, same radius, 3 squared, but this time times by 3, which is the same as 1/3 pi times by 9 times by 3, so times by 27. Right, 1/3 pi times 27 is 1/3 of 27 is just 9, so it's just 9 pi millimeters cubed. So if I add all these three things together, I get the whole lot, so the whole miniature nail is equal to 144 pi plus 135 pi plus 9 pi. Okay, so 144 plus 135 gives me 279, plus 9 gives me 288 pi millimeters cubed. So there's my answer to A. Underline it because that's my answer. Just want it in terms of pi, so no need to decimalize or anything there. Okay, part B. The miniature nail is 1/5 the length of the similar real nail. Using your answer to A, calculate the volume of the actual nail. If the volume is A pi centimeters cubed, find the value of A. Okay. So I want the volume of the real nail. Now the key thing here is I don't just times by 5, because my linear scale factor, which I'm just going to abbreviate to LSF, linear scale factor, is 5. Now the area scale factor is the linear scale factor squared. But I don't want the area scale factor. I want the volume scale factor. So the volume scale factor is 5 cubed. So I have to times the whole thing by 5 cubed. 5 cubed is 125. So I've got 288 times 125, which is, I'll allow you to use a calculator at this point. Right, 288 times 125 equals 36,000. So it's 36,000 millimeters cubed. Not finished, because the question's tricky. It's asking me about centimeters cubed. I've found the millimeters cubed volume. Typical mistake again here would be just to think, right, millimeters, 10 millimeters in a centimeter, so I'm going to divide by 10. That is wrong. This is why it's wrong. Common misconception. Let's think about 10 millimeters. That's 1 centimeter. So if it's a length, then I'm fine. It works, but it's not a length, it's a volume. So I need to think about it. If it was a square, it would be 100th as many centimeters as millimeters squared. But it's not that, it's a volume. So again, this is 10 millimeters or 1 centimeter. So therefore, 1 centimeter cubed, which is what this is, 1 times 1 times 1, is the same as 10 times 10 times 10, 1,000 millimeters cubed. And this diagram is important, it really shows you that. So therefore, I need to divide this, so volume, I need to divide this by 1,000, equals 36 centimeters cubed. And that is my answer. So A, find the value of A if this is the situation, A pi. So I'd left out pi here, didn't I? Sorry about that. I left out pi there, which I shouldn't have done. So this was also 36 pi. So A is equal to 36.